everything I worked out for the work-energy theorem was based on it being the net force. So the work by the net force was equal to the change in kinetic energy. But here's the neat thing. The object is just a single object, which means it only has one set of displacements. It might move right, then left, then right again, right, left. But whatever forces are acting on it, they all have the exact same displacement on this particular object. So when I talk about the work done by the net force, that's the integral of the sum of all the forces in the x direction times dx. But there's no reason I need to sum this first. There's no reason I need to add up the forces before I integrate dx. I could pop that right out the front and say that this is the sum of the integral of individual fx's dx. Maybe we can make that a little more explicit by putting in an I there, an I there. So we're adding up a whole bunch of forces to get the net force, or I can integrate each one of them dx, and this simply becomes the sum of individual works. The reason that's important is that very often we're going to find it's easier to find the work of individual forces and add up those works than it is to add up all of the individual forces. Forces are vectors, and we're going to find that work is a scalar, which makes it quite a bit easier to add. Just a couple other things to tie up here. First, we want to talk about the units for work and energy. In both cases, the units are joules. Now, a joule is a newton times a meter, and it's also a kilogram meter squared over second squared. Remember, newton was a kilogram meter per second squared, and a meter, multiply that times meter, we get kilogram meters squared over second squared, which is exactly what we get here. That makes sense for the work, which was equal to the integral of force dx. Force would be in newtons, x would be in meters. And it also makes sense for kinetic energy, which is 1/2 mass times velocity squared. This will be in kilograms. This will be in meters per second, which gets squared. The other thing I want to talk about is work in everyday terms means effort, whereas work in the physics term means force through distance. Okay, so work in physics means force through a distance. That is, in the physics sense, if you push and push and push on something, but it does not move, then you have done no work on it. That doesn't mean you haven't expended effort, but it just means, in the physics sense, no work has been done. Similarly, if you push and push and push on an object, but your pushing is always perpendicular to its motion, that also will do no work.